In this question, what is the electric field intensity at a point of 10 nanometer away from 100 coulomb of charge in air? It means that here, let's say a charge here, which is actually 100 coulomb, and obviously this is positive. As a result, from this 100 coulomb charge, electric field lines coming out from the 100 coulomb charge, right? Around the, okay. So the question asks like 100 nanometer, 10 nanometer away from this 100 coulomb. So let's say this is the distance r, which is 10 nanometer. So how much electric field intensity will be available at this point, or at this point if it is 10 nanometer, 10 nanometer, 10 nanometer, 10 nanometers, and so on. So we have got Q, we have got R, and the equation for electric field intensity is equals to E equals to K, the constant which is referred the medium is air, and Q over R square. As it is air, so we know the value of K for vacuum is equals to 9 into 10 to the power 9, or 1 by 4 pi epsilon naught, right? For vacuum, actually vacuum medium, but it is air. So what is the relation between vacuum and air? Indeed, we could write down epsilon air is equals to K times epsilon naught, right? K is actually the ratio. This K and this K is not similar one. This is the another one. Anyways, air and vacuum actually are similar. So we actually considering this value for air as well. Indeed, we could plug in the value of 9 into 10 to the power 9, and Q is 100 coulomb over the distance is 10 nanometer. It means 10 times 10 to the power minus 9 whole square. After calculation, we have got 9 into 10 to the power 19 Newton per coulomb. So this is the answer. In this question, calculate the repulsive force between two alpha particles. So two alpha particle, let's say this is one alpha particle, another one is this one. So this is A and this is B, and they are separated by a distance of 10 to the power minus 13 meter, which is very small, tiny distance between these two charges. And of course, the very important thing is the charge of the alpha particle. So let's consider the value of the alpha particle charge, that is, let's consider 3.2 into 10 to the power minus 19. So of course this will given in the question. So Q1 and Q2 will be same because both are the alpha particle. So what is the repulsive force? As they are similar charges, as a result they are repelling each other. So A1 and B1, they are repelling each other. Anyways, the repulsion force or repulsive force is equals to 1 by 4 pi epsilon naught. Here another question is where these two particles are placed. Obviously, either in air or vacuum or any other medium. Here is air. Indeed, we could write down epsilon A. Honestly speaking, the value of epsilon naught air and epsilon air is very tiny difference. So in this context, we are taking 9 into 10 to the power 9. Unit will be Newton meter square per Coulomb square. This is actually also given in this question or in your exam. Obviously, the question or teacher, they will ask the question, and obviously they will give in this value as well within the question. Anyways, and the formula q1 q2 over r square, the distance between these two particle. Now plug in 9 into 10 to the power 9, and of course 3.2 and 10 to the power minus 19. These two charges are similar. As a result, value also be similar. That's why I put two values square, and the distance, that is actually 10 to the power 10 to the power minus 13 whole square. So after calculation, the value of the repulsive force is 9.21 into 10 to the power minus 2 Newton. So this is the answer. So this amount of repulsive force will be arised here if two particles are separated by distance of 10 to the power minus 30 meter. Distance between two positive charges in air is 0.1 meter. So here, and another one is here. So this is A and this is B. Two positive charges, as it is two positive charges. So let's say this is Q1 and this is Q2. Both are positive. They are separated by distance of 0.1 meter. And as they both are positive charges, as a result, within these two charges, a repulsive force arises, which is 9 into 10 to the power minus 5 Newton. The repulsive force is this one. If one charge is 4 times than the another, so the condition or the information Q1 is equals to Q and Q2 is equals to, let's say, 4 times. So determine the magnitude of this charge. So we have to determine the value of Q1 and Q2, right? So the force F is equals to, so within the air, let's write down the value of 9 into 10 to the power 9, the constant value, and Q1 is Q and Q2 is 4Q and R means 0.1, right? So the value of force is 9 into 10 to the power minus 5. So here will be 4 times 9 into 10 to the power 9 and Q square over, by the way, this will be square as well. So 0.1 whole square. So we could write down Q is equals to 5 times 10 to the power 9 Newton. So Q1 is 5 times 10 to the power 9 Newton. And if we going to determine the value of Q2, so this is actually the Q1, right? And Q2 is equals to 4 times this value. So 4 times 5 is 20 into 10 to the power 19 Newton. So this will be 20 into 10 to the power 9 Newton. So this is Q1 and this is Q2. So this is the final answer. In this problem, let's say this is a pitch ball. The mass of the ball is 0.002 kgs. As a result, the weight W is mg. So the value of m is 0.02 into 9.8. So the value will be 0.0196 Newton. On the other hand, the electric field, if you like to keep the pitch ball stationary, indeed we have to have the electric field E equals to F by Q. So here the weight of the pitch ball is actually the force of the ball, pitch ball actually. So this is actually 0.0196 and Q is 10 to the power minus 4 Coulomb, and this will be Newton. So the electric field will be 196 Newton per Coulomb. So this is the answer for the electric field. Now the question, the pitch ball either stationary in a gravitational field or not. If the W is equals to the electric field, if it is equal, in that case we could say the pitch ball will be stationary, right? In this problem, the radii of two sphere, so this is one sphere, another one is here. So sphere A and sphere B, the radius, let's say R1 is equals to 0.01 meter, and here another sphere, so this is R2 is equals to 0.02 meter, and they charged with 50 Coulomb and 100 Coulomb. So this is comparatively smaller. Charge also smaller compared to the second one, which is actually 200 Coulomb. What is the ratio of the surface density of two sphere? It means here the charges, so here the charges density, here also the charges density, right, around this sphere. This density ratio we have to determine. In this case, what we have to do, we have to determine sigma 1, the surface charge density for a sphere, Q1 over 4 pi r1 square, same as for B sphere, so it will be Q2 over 4 pi r2 square. So what we have to do, we have to determine the sigma 1 is to sigma 2. This ratio we have to determine. So let's say this is equation 1 and let's say this is equation 2. Now if we'd like to calculate or determine the ratio, indeed we have to divide these two equations. As a result, we will have sigma 1 over sigma 2. Now this will be q1 and this is 4 pi r1 square. Now if we multiply here, as a result this will be 4 pi r2 square and this is q2. If we plug in all this value, before that we could cancel out this 2 and q is 100 and q2 is 200, right? By the way, if we calculate, we have the result 2 over 1. As a result, the value of the surface charge density sigma 1 equals to sigma 2 will be 2 is to 1. This is the answer. In this problem, two positive charges, each of the charge is 10 Coulomb, are placed on a circumference of the circle. So this is the circle which radius is 10 centimeter, and at the circumference we placed two charges. So one charge is this one, which is actually 10 Coulomb. Another one, let's say, plug here or placed here, which is also 10 Coulomb. What we have to determine, at the center here, what will be the potential V is equals to what? Indeed, the equation or the formula for the potential V is equals to 1 by 4 pi epsilon naught, and let's say this is vacuum, so we could write down 1 by 4 pi epsilon naught, and the charge is Q and distance is, let's say, R, of course the radius of the circle. So this is 9 into 10 to the power 9 and Q is 10 Coulomb over R is 10 centimeter, means 0.1 meter. So we have 1.8 into 10 to the power 12 volt. So this is the answer. Two small spheres, one is, let's say, this one, another one is this one, and this is positive 16 Coulomb and this is positive 25 Coulomb. They are separated by a distance of 0.25 meter. And here another point is very important to determine, that is, at what point on the joining line, I mean this straight line axis, the null point or neutral point can be found. So as we see, this is 16, this is 25, so this is higher, so the null point is close to the 25, and this is positive, it means that the electric field are repulsing, or the force also repulsing. As a result, at this point, let's say we find the null point. So up to this distance is x, and this is 0.25 minus x distance. So for very fast charge, the electric field E1 is equals to 9 into 10 to the power 9, the value of k, and the charge is 16 and the distance is x squared. Same as for this charge E2 is 9 into 10 to the power 9, 25 over 0.25 minus x whole square. And at the null point, of course, the net electric field is 0. It means E1 is equals to E2. Now plug in all this value here. So this is 9 into 10 to the power 9, 16 over x square, 9 into 10 to the power 9, 25 over 0.25 minus x whole square. So this one cancel out. So we could write down x over 0.25 minus x whole square equals to 16 over 25. So x over 0.25 minus x equals to 4 over 5. So by using calculator, we have a result of x is equals to 0.11. In this problem, the potential difference between 2 points located in a uniform electric field is 200 volt. It means if we applied within this 200 volt, indeed here will be a uniform electric field occurred. So here 2 points or 2 point plates or 2 charge plate. So for uniform charge, we have to have a positive charge and have to have a negative charge. Or when we apply a voltage, obviously there will be a potential difference. So one will be positive, another will be a negative charge. Indeed, here will be a uniform electric field will be occurred, right? So from positive to negative, the electric field line shows as I drawn here, and the distance between these two charge plate, that is 50 centimeter. So the distance between these two plates is 50 centimeter. What we have to determine? We have to determine the electric field intensity E. So we know the potential or the voltage is equals to the electric field and the distance. So the electric field E is equals to V over D. So after plugging this value, we have 400. So unit of volt is volt and this is meter. So electric field is 400 volt per meter. I have a question for you, all of you. We know that the unit of electric field is Newton per Coulomb, and here we have got volt per meter. Is it possible? Can you please convert this Newton per Coulomb to volt per meter? Please do it and send to our community of School of Next Gen tutorial. Have a nice day. Thank you. How much work done is required to transport a charge of 60 coulomb on a terminal? So this is a terminal actually, and within a terminal, let's say here is the voltage, it is 10 volt, and of course this is a closed loop. And if this battery, we have a charge of 60 coulomb, Indeed, what is the work done? So we know volt is equals to work done over Q, or the charge. So work done, W is equals to V times Q. So this is 60 volt times, 60 Coulomb charge times 10 volt. So all together we have got 600 joule. So this is the answer. A potential 150 applied between two plates. So here, let's say positive charge and negative charge. So this is positive charge and this is negative charge. These are the two plates. The electric field intensity between these two plates, that is actually 500 volt per meter or Newton per Coulomb. What is the distance between these two plates, whereas the voltage is 150 applied? So we know volt is equals to E d, or d is equals to V over E. So the value of V is 150 and E is 500. So we have got 0.03 meter, or let's comment what will be the value in centimeter. Here is a square, three charges. One is positive 4, 10 to the power minus. Indeed, we could write down 4 nanocoulomb, and here need to be write the negative 1. So 4 nanocoulomb here as well, 4 nanocoulomb here also positive. And at this corner, what will be the potential here? I mean to say, determine the potential at fourth corner. So we have to determine the V of A in terms of these three charges. Indeed, what we have to determine the corner, and what we also have the data within the question. One is the side is 0.2 meter. So this is 0.2 meter, also 0.2, also 0.2 meter. So the value of Q1 is equals to 4 nanocoulomb, Q2 and Q3 we have, right? These three value we have. So VA, I mean to say, if it is A point, fourth corner, so VA is equals to, we could write down VB if it is B, if it is C, and if it is D. So VB plus VC plus VD. So for V is equals to, we could write down 1 by 4 pi epsilon naught into Q over the R. So for each of the potential, 1 by 4 pi epsilon naught is common. So let's write down 1 by 4 pi epsilon is common. Now Q1 over R1 plus Q2 over R2 plus Q3 over R3, right? Here, the very important thing is to determine the value of R1, R2, and R3. So, for B and C, the R is 0.2 and C and D is 0.2, but in between point B and D, it will be R3. So we have to determine the value of R3, which is the corner of the square. So R3, let's change the color. This is not properly visible. So let's use the white one. So R3 is equals to square root of, so this is the R3. So this is the triangle. One side is 0.2, another side is 0.2, and this is the hypotenuse. So hypotenuse R3 is equals to 0.2 square plus 0.2 square. So R3 is equals to, we could write down 0.283 meter. Now plug in all this value. So this is 9 into 10 to the power 9. So Q1 is 4 into 10 to the power minus 9 over 0.2 plus 4 into 10 to the power minus 9. So this is actually the minus 1. That's why it will be minus. And here will be 283. Actually, this is R3. Let's write down here RD. This is B and this is C. More clear. So this is 4 into 10 to the power minus 9 over 0.2. If we use calculator, we have a value of 233 volt. So this is the final answer. Charge of 2 nanocoulomb placed at the corners of the square. So corner A, corner B, corner C, and corner D. All of this corner have got the charge of 2 nanocoulomb, 2 nanocoulomb, 2 nanocoulomb, and 2 nanocoulomb as well. And the corners of the square, this one, and the corners, this one, these two corners are similar. And the another information which is very important to solve this problem, that is the side of the square is 2 meter each. So this is also 2, this is also 2, this is also 2, right? So we can determine by using these sides 2 meter. So corner, I mean the diagonal of these two corners, let's say this is A and B, or maybe C and D as well, these are same. So the diagonals AB is equals to CD square root of 2a square plus 2a square. So 8 square. So 4 plus 4, so 8 square. So this is actually the diagonals AB. Now at the middle point, let's say O. So OA is equals to OB is equals to OC is equals to OD is equals to square root of 8 over 2. Indeed, we could write down square root of 2. Now, the very important thing is the question. What is actually we have to determine? That is, we have to determine the potential at the center. It means that at this center, what is the potential? So V is equals to VA plus VB plus VC plus VD. So there are four corners. The value of the potential is VA, VB, and VC, and VD as well. So we know the formula for VA, and from the formula we know that 1 by 4 pi epsilon naught. This term will common for each of the potential. So VA is equals to Q1 over R plus Q2 over R plus Q3 over R, I mean the distance, and Q4 over R, right? Why all the distances are similar? Because at the center from the corner is OA, OB, OC, OD, all are same. That's why this is R. So the R is also common, and the value of Q1, Q2, Q3, Q4 all is 2 nanocoulomb. So there are actually four terms, 1, 2, 3, 4. All of these are equal. That's why we could write down 9 into 10 to the power 9, and this is 4, and Q is 2 into 10 to the power 9 over R is square root of 2. After using calculator, what we have the final result, that is actually 50.91 volt. So this is the final answer. At the center, 50.91 volt or potential can be arise. Here I have a homework for you. So this is the square we have solved. At the center, the total potential is this much. I have a question. Let's say at a corner, at this corner A, what is the potential at VA? Please comment in this section. Thank you. A sphere radius is 0.5 meter from the center. So from the center up to this length is 0.50 meter. And obviously this sphere is full of charged. So let's consider everywhere the sphere is full of charged. Doesn't matter either here positive charged or maybe negative charged. That not actually very important issues for this problem. We have to determine the potential at the point from the center, so up to this much, which is 0.4 meter. So at here, maybe here, or maybe here, from center to 0.4 centimeter, what is the potential that we have to determine? So case number one, 0.40 meter potential. Here, one important issue is inside the sphere, everywhere the potential is equal to the potential at circumference. So the potential at the circumference of the sphere is equal to everywhere inside the potential. So what we have to do, we have to determine the potential at the circumference. Indeed, what you have to do, V is equals to 1 by 4 pi epsilon naught into Q over R. So here, let's say the charge within this sphere is, let's say, 20 Coulomb, and radius we have 0.50. So 9 into 10 to the power 9 into 20 over 0.5. So what we have, 3.6 into 10 to the power 11 volt. So this amount of potential may be here, maybe here, maybe here, everywhere the same potential felt by the sphere if the radius is 0.5. Now the another point, what will be the potential far away from 0.8 meter? It means from the center to somewhere maybe here, which is distance 0.8 meter. Indeed, what we have to do, we have to change within this equation. So V equals to case number 2, this one, case number 2, and here the distance is 0.8 meter. So 9 into 10 to the power 9, value of Q is of course 20, and the distance now increased. So this is 0.8. So it will be 2.25 into 10 to the power 11 volt. So the conclusion, we could say, from the center up to circumference, everywhere the potential is same, which is depend on the radius of the sphere. So the bigger sphere, it means the radius increased, the potential will be decreased. And from the center, if the distance far away from the sphere, the potential also decreased. So for 0.5 or 0.4, that is 3.6 into 10 to the power 11. And if it is 0.80, it means distance increased. Indeed, the potential is decreased compared to the first potential, first case, which is 0.40 or 0.50 distance. Thank you. In this problem, 3 capacitors. So capacitor number 1, which is C1, the value is 3 farad, another one is 4, another one is 2. Determine their equivalent capacitances if the combination is connected to 300 source voltage. So they are actually connected in series, though the connection system is not directly given in the equation, but we have to understand the equation as the connection directly with the source. It means it is connected in series. So C1, C2, C3, and the voltage is 300 volt. What we have to determine? We have to determine the equivalent. It means that by the formation of these 3 capacitors, what will be the total value or the series combination, that is actually CS, will be what? Indeed, we know that when the capacitors are in series, so let's say capacitors in series, indeed we could write down 1 by CS, the combinational value, which is CS, equals to 1 by C1 plus 1 by C2 plus 1 by C3. So here we have got the value of the CS is equals to 3.71 microfarad. If the value, let's say in microfarad, though we have written here farad, but let's say we considering this is microfarad. If it is microfarad, all the value, so our final value will be 3.17 microfarad. Now the second part, calculate the energy stored and the total energy. So we have to determine the total charge stored within the capacitors or the combinations and the total energy produced by the or stored by the capacitors. So for very first part, the total charges Q equals to CV. So the total charge stored by the capacitors, that is C, is 3.71 into 10 to the power minus 6, as this is micro, and the value of the potential, that is voltage, that is actually 300. So we have got the final answer will be 1.14 into 10 to the power minus 3 Coulomb, or we could write down 1.14 millicoulomb. This is the second part of this question, and the final one, the total energy. So the total energy U is equals to half C V square. If we plug in all this value, let's say 0.5, the total capacitance, this is 3.71 microfarad, and V is 300 whole square. After plug this value and this one here, and final result will be 0.167. This is the total energy of this capacitance. I mean the total stored energy by this combination of series capacitors, that is 1.167 joules. Problem: the parallel plate capacitor, the radius of each plate is 0.1 meter. Distance between the plates is 1 millimeter. It means the capacitor, actually this is one plate, let's say this is another plates, and these two plates actually circular because they are actually given the radius of the plate is 1.1 meter. So up to this length is 0.1 meter each. It means both the plates are equal, and the distance between these two plates, let's say from the center of this plate up to this one, let's change the color. So the length is 1 millimeter. What we have to determine first, the capacitance of the capacitor. So the very first one, we have to determine the capacitance of the capacitor formed by two parallel circular plates. The value is given here. So the formula for capacitance, C is equals to epsilon naught, the permeability of any medium. Of course, here the medium is not given in this question. Let's consider the medium is vacuum. Of course, the value of capacitance depend on the medium. but here we are assuming the medium is vacuum within these two plates are placed anyways, and the area over the distance between two plates. Now, what is area? Area is the plate area. So this will be pi r square. So this is pi and r is 0.1 whole square. So if we plug in all this value, what we have got 2.78 into 10 to the power minus 10 farad. And number 2, this is answer for number 1. So 1 done. Now electric field intensity between these two plates. Indeed, when there are two plates, indeed obviously they have connected, of course, as they are a capacitor, and they are connected by a potential difference of 100 volt. Indeed, the electric field is equals to V by D. So V is 100 and D is 1 millimeter. So we have got the value of electric field is 10 to the power 5 volt per meter or Newton per Coulomb. This is the unit of electric field. Now number 3, the energy stored between the plates. So here the amount of energy we have to determine. So this is of course the potential energy. So U is equals to half C V square. Now plug in the value. So we have got 1.39 into 10 to the power minus 6 joule. Last one, the energy stored per volume. It means that we have to determine the energy density of the capacitor or the parallel plates. So number 4, the per volumetric energy, let's say this is the density, so UD is equals to the equation formulated half epsilon naught and the value of U. So if we plug in epsilon naught for vacuum is 8.85 into 10 to the power minus 12. We have to plug in half and U is this much. So plug all this value, we have got 0.0443 joule per meter cube. So this is the final answer for number 4. In this problem, 64 spherical drops, let's say this is the spherical drops, let's say here is 64. Each of the drops radius is, let's say this is the radius, all are same, so the radius is 0.02 meter. So this is smaller r equals to this much. Now the combination or combine to form a single large drop. So combine all this 64 drops. So here n is equals to 64 drops here. So combining this drop, 64 drops, formed a large single drop, and the radius of this large drops is r. This is not actually given. If each of the small drops carries 1 coulomb. So each of the drops carries 1 coulomb of charge. We have to determine the potential and the capacitance of the large drop. So we have to determine everything for the large drop. So we could write down according to condition that the volume of the large drop 4 by 3 pi r cube is equals to the total number of, so we could write down 64 and 4 by 3 of each of the small drops volume, so pi by r cube. So 4 by 3 cancel out, pi cancel out. Now we could write down r over r whole cube is equals to 64. Now we know the value of r, so r cube is equals to, or we can write down the final value. Let's say the r is equals to 0.08 meter, as the value of smaller r is 0.2 meter. Now what we have to determine the capacitance of the large drop. So the capacitance of the large drop, C is equals to 4 pi epsilon naught into the radius, as the drop is spherical. That's why the formula for the spherical capacitance of any radius, that is 4 pi epsilon naught, because within the sphere the medium is determined epsilon naught. It could be air, it could be vacuum, anything, doesn't matter. So now plug in the value. We have got 8.9 into 10 to the power minus 12 farad. Now what we have to determine? We have to determine the potential of the large drop. So the potential of the large drop, V is equals to 1 by 4 pi epsilon naught, and the charges over the radius. So this one. So if we plug in all the value, so it will be 7.2 into 10 to the power 12 volt. So this is the final answer for the potential.